In the time it takes you to watch this video, light from the most distant galaxy we've ever discovered will travel another 300 million miles toward us. That light began its journey when our universe was barely 280 million years old, long before Earth, before our Sun, before the Milky Way even resembled what we see today. Everything you thought you knew about how many galaxies exist is wrong. Until recently, astronomers estimated around 200 billion galaxies in our observable universe. That number already felt impossibly vast. Then the James Webb Space Telescope turned its infrared eyes towards seemingly empty patches of space and shattered that estimate completely. The real number, 2 trillion galaxies. For every galaxy we thought existed, 9 more were hiding in cosmic shadows, too faint and distant for previous telescopes to detect. The Hubble Space Telescope gave us our first hint when it captured the ultra-deep field, a patch of sky smaller than a grain of sand held at arm's length. In that tiny slice of apparent emptiness, Hubble found 10,000 galaxies. That region represents just 1/13,000,000th of the entire sky. Webb's infrared vision revealed galaxies so distant their light has been stretched from visible wavelengths into infrared radiation, showing us the universe's baby pictures. Right now, you're hurtling through space at over 1,000,000 miles per hour. You're not just spinning with Earth or orbiting the Sun, you're being carried by the Milky Way itself as it barrels toward an inevitable cosmic collision. Our galaxy belongs to the local group, a gravitationally bound cluster of more than 54 galaxies spanning roughly 10 million light-years. 3 galaxies dominate this neighborhood. The largest is Andromeda, containing over a trillion stars and stretching 220,000 light-years across, roughly twice our size and heading straight toward us at 68 miles per second. The collision is confirmed for approximately 4.5 billion years from now. Our Milky Way ranks second with an estimated 300 billion stars spread across 100,000 light-years. We're positioned about 26,000 light-years from the galactic center in the Orion Arm. The third major player is Triangulum, containing roughly 40 billion stars and notable for having one of the highest star formation rates in the local group. But the peaceful appearance masks a violent reality. The Milky Way has been eating its neighbors for over 10 billion years. Right now, our galaxy is violently tearing apart and consuming at least 2 smaller galaxies. The Sagittarius dwarf elliptical is being slowly shredded, leaving streams of stars that wrap around the Milky Way like cosmic spaghetti. The Canis Major dwarf was so thoroughly destroyed that astronomers only discovered its remains in 2003. This isn't gentle. Dwarf galaxies get stretched and twisted by tidal forces that rip individual stars away and fling them into our outer halo. The evidence is written in the stars themselves. Astronomers can identify which stars originally belonged to destroyed galaxies by studying their chemical composition. The Sagittarius dwarf's disruption is triggering waves of star formation throughout our spiral arms, creating stellar nurseries where new stars are born at accelerated rates. The Large and Small Magellanic Clouds are next. These galaxies, visible from Earth's southern hemisphere, aren't in stable orbits. They're expected to be fully consumed within the next 2 billion years. When the Large Magellanic Cloud finally merges, the collision will trigger massive bursts of star formation and potentially wake up the supermassive black hole at our galaxy's center. This galactic cannibalism isn't unique to us. Andromeda has been even more aggressive, having devoured at least 10 different dwarf galaxies. The remains are still visible as faint streams of stars stretched across hundreds of thousands of light-years. In 4.5 billion years, the night sky will be on fire. Andromeda is aimed directly at the Milky Way's heart. When galaxies collide, it's not like solid objects smashing together. Galaxies are mostly empty space. The chance of any 2 stars actually hitting each other is essentially 0. Instead, something far more dramatic happens. The collision will unfold over hundreds of millions of years. Massive tidal forces will fling entire star systems into the dark void between galaxies. As the galactic centers draw closer, their supermassive black holes will begin a deadly spiral dance. The Milky Way's black hole contains about 4 million solar masses, while Andromeda's holds roughly 100 million. When these monsters merge, they'll create gravitational waves detectable by civilizations billions of light-years away. The merger will trigger spectacular fireworks. Gas clouds from both galaxies will collide and compress, igniting massive star formation, 10 times faster than what we see today. Computer simulations suggest a 50% chance our solar system will be flung 3 times farther from the galactic center. There's also a 12% chance we'll be ejected entirely. If humanity still exists, we'll have front-row seats. The night sky will gradually fill with new stars as Andromeda grows larger and brighter, eventually dominating the entire sky. The final product will be a giant elliptical galaxy astronomers have nicknamed Milkomeda. There are galaxies out there that have been dead for billions of years, and scientists have no idea how they died. MACS 21291 stopped forming new stars over 10 billion years ago, making it a cosmic zombie. According to our models, this should be impossible for a galaxy of its size and type. Dead galaxies are systems where star formation has completely shut down. In normal galaxies, massive clouds of gas constantly collapse to birth new generations of stars, a process that should continue for trillions of years. But MACS 21291 defied this natural order when the universe was less than a quarter its current age. Small galaxies can be quenched relatively easily, but massive spiral galaxies should have enough gravitational pull to hold onto their gas. MACS 21291 maintained its spiral structure even as it died, like finding a perfectly preserved mummy that looks alive from the outside, but contains no spark of life within. Several theories exist. Perhaps the galaxy's central supermassive black hole went through an extremely active phase, heating surrounding gas so it could no longer collapse into stars. Or maybe massive supernova explosions collectively blew away its entire gas supply. The most disturbing possibility: we're missing something fundamental about galaxy evolution. Some galaxies are being torn apart so violently they look like jellyfish. ESO 137001, located 220 million light-years away, appears to be swimming through space, trailing long tentacles of gas and stars, but this galaxy is drowning. The destruction comes from ram pressure stripping. ESO 137001 is racing through the Perseus galaxy cluster at over 1.0 miles per second. The space between galaxies isn't empty, it's filled with extremely hot gas heated to over 100 million degrees Fahrenheit. When moving through it at cosmic speeds, it becomes like hitting a brick wall. The ram pressure is literally stripping away the galaxy's gas supplies, creating spectacular trails stretching over 200,000 light-years. These trails contain enough material to form billions of new stars, but instead of fueling growth, this precious gas is being scattered into the void. The stripped gas forms structures resembling jellyfish tentacles, illuminated by ultraviolet radiation from young stars still forming within. The process is irreversible and ultimately fatal. Once a galaxy loses its gas, it can no longer form new stars. Eventually, only dim red dwarf stars will remain, turning the once vibrant galaxy into a cosmic ghost. There's a galaxy that shouldn't exist, and its presence is breaking our understanding of how the universe works. NGC 1277 contains virtually no dark matter, like finding a skeleton without bones. Dark matter makes up roughly 85% of all matter in the universe and provides the invisible scaffolding that allows galaxies to form. Without it, galaxies should either fly apart or never form at all. Yet NGC 1277 sits there, apparently held together by nothing but the gravity of its visible stars. Dark matter acts like invisible glue holding galaxy clusters together. It's what allows spiral galaxies to spin without flying apart. NGC 1277 is what astronomers call a relic galaxy. It formed early in cosmic history and remained largely unchanged for billions of years. Despite containing hundreds of billions of stars, it has virtually no dark matter halo. One explanation: NGC 1277 formed through an extremely rare process where normal matter separated from dark matter during the galaxy's birth. Another: the galaxy's dark matter was stripped away by gravitational interactions with the massive Perseus galaxy cluster. The most disturbing possibility: our entire understanding of dark matter is fundamentally flawed. There's a galaxy in the early universe where gas clouds shine brighter than all the stars combined. GSNDG 9422 exists from when the universe was only 1 billion years old. When astronomers examined its spectrum, they found something never seen before: superheated gas actually outshining the galaxy's entire stellar population. The galaxy's gas clouds are heated to over 140,000 degrees Fahrenheit, nearly twice as hot as typical massive stars. The spectrum showed signatures of highly ionized gas, meaning atoms have been stripped of most electrons by intense radiation. This requires far more energy than the galaxy's observed stars should provide. The team concluded that GSND G9422 contains stars much hotter and more massive than anything in the local universe today, primordial monsters reaching temperatures of over 140,000 degrees at their surfaces. This gas-dominated galaxy might show us exactly how cosmic reionization happened, when something ionized all the neutral hydrogen to make the universe transparent. The James Webb Space Telescope has found galaxies so massive and formed so early that they're breaking our models. 3 galaxies nicknamed the Red Monsters contain as much mass as our Milky Way, but existed when the universe was less than 1 billion years old. According to our theories, these massive systems shouldn't have had time to assemble so early. Galaxy formation was supposed to be gradual. Small clumps of dark matter slowly grew larger, eventually becoming massive enough to trap gas and form stars, a process taking billions of years. But the red monsters compressed this entire sequence into less than 1 billion years, forming stars at nearly twice the rate of similar mass galaxies today. The red monsters managed to hold onto their gas and convert it into stars with unprecedented efficiency, overcoming natural limitations that should have prevented such rapid growth. If massive galaxies could form this efficiently in the early universe, it suggests the cosmic environment 1 billion years after the Big Bang was fundamentally different from today. We are looking at the most distant object ever discovered by humanity. JADS C14-0 existed when the universe was only 280 million years old. This galaxy represents the ultimate time machine, showing us conditions when our cosmos was barely 2% its current age. The light reaching us began its journey over 13.5 billion years ago, when the first stars were just beginning to illuminate a dark universe. The galaxy's discovery required pushing Webb to its absolute limits. Even with unprecedented infrared sensitivity, it appears as just a few pixels of reddish light. But those pixels contain information that has traveled farther through space and time than any signal humanity has ever detected. The extreme distance means we're seeing it at a redshift of Z equals 1444, its light stretched by a factor of over 15. What makes it even more remarkable is that it's surprisingly massive and bright for such an early galaxy, containing several hundred million solar masses packed into a region spanning roughly 1,600 light-years. The galaxy appears in the midst of furious star formation, creating new suns at a rate that would build our entire solar system every few years. This level of activity produces so much ultraviolet radiation that it ionizes surrounding gas, creating a bubble of transparency in an otherwise opaque universe. The discovery raises profound questions about how structure formed in the early universe. Current models predict it should have taken longer for dark matter halos to grow massive enough to host such bright galaxies. The galaxy's existence suggests either that galaxy formation was more efficient than we realize, or that the early universe contained physical processes we haven't yet discovered. The epoch between 200 million and 1 billion years after the Big Bang represents the most dramatic transformation in cosmic history, cosmic dawn. This era witnessed the birth of the first stars, the formation of the first galaxies, and the complete restructuring of all matter from a dark neutral fog into the transparent star-filled cosmos we see today. Before cosmic dawn, the universe was literally dark. No stars existed to produce light. Space was filled with invisible neutral hydrogen gas and mysterious dark matter. Hidden within this darkness, gravity was slowly assembling the first structures. The very first stars were unlike anything today. Population III stars formed from pure hydrogen and helium, monsters containing hundreds of solar masses and burning hot enough to synthesize the first carbon, oxygen, and iron. These stellar behemoths lived fast and died young, exploding as hypernova after just a few million years. Webb is giving us direct glimpses of cosmic dawn, detecting galaxies from this crucial epoch. What's emerging is a picture far more violent and chaotic than expected. Early galaxies are more massive, more active, and more numerous than our models predicted. Two galaxies have been locked in a cosmic death spiral for over 600 million years. The antennae galaxies, located 68 million light-years away, earned their nickname from spectacular tidal tails that stretch from their distorted cores like cosmic insect antennae. These aren't gentle appendages, they're streams of stars, gas, and dark matter being violently torn from their parent galaxies. The collision began around 600 million years ago when both were probably beautiful spiral systems. As they drew closer, mutual gravity distorted their shapes, pulling stars and gas into long streamers now stretching over 200,000 light-years into space. But the most spectacular part is the burst of star formation. When gas clouds collide, they compress and heat up, creating ideal conditions for new stars. The antennae system is currently birthing stars at a rate roughly 10 times higher than normal galaxies. Hubble has revealed that the collision is creating some of the most massive star clusters ever observed, stellar metropolises containing millions of stars packed into regions just a few dozen light-years across. Computer simulations show the galaxies are still approaching maximum violence. Over the next few hundred million years, their cores will spiral closer, triggering even more intense star formation. Eventually, their central supermassive black holes will merge, sending gravitational waves rippling across the universe. Everything you can see in the universe is built on a foundation of something completely invisible. Dark matter makes up 85% of all matter, yet it interacts with nothing except gravity. It doesn't emit, absorb, or reflect light. It's essentially the ghost of the cosmos, detectable only through gravitational fingerprints. Think of dark matter as the skeleton giving shape to the cosmic body. Without it, the universe would be a smooth, featureless soup with no structure at all. When astronomers measure how fast stars orbit galaxy centers, they find out a star's moving much too quickly to be held by visible matter alone. Something invisible must provide extra gravitational pull. Modern techniques have allowed astronomers to map dark matter distribution using gravitational lensing. Massive concentrations bend and distort light from background galaxies, creating a cosmic funhouse mirror effect revealing where invisible matter is located. These maps show dark matter forms a vast web-like structure spanning billions of light-years. Every galaxy sits at the center of a dark matter halo, extending far beyond visible stars. Our Milky Way's halo stretches at least 600,000 light-years from the galactic center, 3 times larger than the visible galaxy, containing roughly 10 times more mass than all our stars and gas combined. Computer simulations show that without dark matter, the universe would look completely different. The tiny density fluctuations after the Big Bang would never have grown large enough to form the first stars and galaxies. Yet despite decades of searching, scientists still have no idea what dark matter actually is. Hidden throughout the universe are massive dark matter structures containing no stars, no gas, and no light whatsoever. These dark galaxies have enough mass to qualify as galaxies, billions of solar masses, but emit no light across any wavelength. They're essentially invisible cities of dark matter, detectable only through gravitational effects. Finding these invisible objects requires detective work. Astronomers look for gravitational signatures by studying how they bend light from background galaxies. One compelling candidate discovered through gravitational lensing contains roughly 1 billion solar masses but produces no detectable light. It's like finding a city-sized building that casts a shadow but is completely invisible. Your cosmic address is far stranger and more vast than you could imagine. Most people know they live in the Milky Way, but that's like saying you live in a house without mentioning the city or continent. Your full address includes the local group, the Virgo cluster, and ultimately the Laniakea supercluster, a gravitationally connected structure containing over 100,000 galaxies spread across 520 million light-years. Laniakea wasn't discovered until 2014. The name means immense heaven in Hawaiian. The discovery came from mapping peculiar motions of galaxies throughout our region. While expansion carries most galaxies away, gravity creates additional motions as galaxies are pulled toward massive concentrations of matter. What they found was astounding. The Milky Way, Andromeda, and tens of thousands of other galaxies are all flowing toward a massive gravitational attractor at Laniakea's center, pulling our entire cosmic neighborhood at over 1,000 miles per hour. But Laniakea itself flows toward an even larger structure called the Shapley attractor, located roughly 700 million light-years away. The universe is built like a cosmic spiderweb, with massive filaments stretching across distances, so vast they make entire superclusters look like tiny decorations. These galaxy filaments are the largest known structures, commonly reaching 160 to 260 million light-years, but some are true cosmic monsters. The Hercules Corona Borealis Great Wall stretches over 10 billion light-years across space, roughly 1/10 the diameter of our entire observable universe. These filaments form the backbone of cosmic architecture, connecting galaxy clusters and superclusters in a vast three-dimensional web spanning the entire universe. The pattern resembles a neural network with dense nodes connected by elongated strands and vast empty spaces between. The cosmic web emerged from tiny quantum fluctuations after the Big Bang. During cosmic inflation, these microscopic variations were stretched to astronomical scales. Over billions of years, gravity amplified these differences, causing matter to flow along paths of least resistance. The space between galaxies within filaments isn't empty. It's filled with warm, hot intergalactic medium, tenuous gas heated to temperatures between 100,000 and 10 million degrees Fahrenheit. This gas is so thin it barely qualifies as matter by Earth standards, but there's so much spread across vast volumes that it contains more normal matter than all the stars in all galaxies combined. Between the massive filaments and great walls lie cosmic voids, the largest empty spaces in the universe, spanning hundreds of millions of light-years with almost no galaxies, stars, or even dark matter. If Earth were located in the center of a typical void, we wouldn't have discovered other galaxies existed until the 1960s. The Boötes void spans roughly 330 million light-years in diameter, but contains almost no galaxies. If the Milky Way had formed in its center, the nearest galaxy would be over 150 million light-years away, invisible to all but our most powerful telescopes. The average density of matter throughout the universe is roughly 6 hydrogen atoms per cubic meter. Within cosmic voids, density drops to less than 1/10 this universal average, creating regions emptier than the best vacuums we can create in laboratories. These voids didn't form through cosmic explosions. They represent regions where initial matter density after the Big Bang was slightly lower than average. Right now, 4 massive galaxy clusters are colliding in the most violent event our universe has witnessed since the Big Bang itself. The collision in MACS J0717, located 5.4 billion light-years away, involves clusters each containing hundreds of galaxies and trillions of stars, plus enormous quantities of hot gas and dark matter. When objects this massive collide, they release more energy than billions of supernovae simultaneously. The Chandra X-ray Observatory has captured stunning images, revealing hot gas within each cluster glowing at over 100 million degrees Fahrenheit. As clusters merge, their gas clouds collide and compress, heating to even more extreme temperatures and creating shock waves propagating outward for millions of light-years. The most fascinating aspect is how the collision separates different types of matter. The hot gas experiences friction and turbulence, causing it to slow down and lag behind, but galaxies themselves, being much denser and more compact, pass through with relatively little interaction. This creates a situation where galaxies become separated from their own hot gas. Between every galaxy flows a cosmic river of gas heated to temperatures, making the sun's surface seem cool. The intergalactic medium is filled with plasma heated to over 10 million degrees Fahrenheit, so hot that atoms are completely stripped of electrons. This material is so tenuous it would count as perfect vacuum by Earth standards, yet it contains more normal matter than all the stars in all galaxies combined. These cosmic rivers follow dark matter filaments connecting galaxy clusters, creating a circulatory system, transporting matter and energy across billions of light-years. Gas flows along these channels like blood through cosmic arteries, carrying raw materials needed for galaxy formation. The intergalactic medium is largely invisible to optical telescopes because hot plasma doesn't emit much visible light. Instead, astronomers detect it using X-ray telescopes. Recent observations have revealed vast networks of hot gas connecting galaxy clusters across hundreds of millions of light-years. The most dramatic discovery came from fast radio bursts, brief flashes from distant galaxies acting like cosmic lighthouses illuminating the intergalactic fog. By studying hundreds of fast radio bursts, astronomers confirmed that roughly half of all normal matter exists in this hot intergalactic state, solving the decades-old missing baryon problem. In what appears to be the emptiest patch of sky imaginable, Hubble found 10,000 entire galaxies hiding in darkness. The Hubble Ultra Deep Field required astronomers to point the telescope at a tiny region in the constellation Fornax that appeared completely empty, smaller than a grain of sand at arm's length. Yet Hubble stared for over 11 days, collecting 800 separate exposures to create the deepest image of space ever obtained. What emerged changed our understanding forever. That apparently empty patch revealed galaxies scattered like cosmic jewels across billions of years. Nearly every point of light represents an entire galaxy, containing billions of stars, planets, and potentially civilizations we'll never know about. The image serves as a cosmic time machine. The nearest galaxies appear as they were millions of years ago, while the most distant show us the universe when it was less than 1 billion years old. Some galaxies are among the first ever formed, cosmic pioneers that assembled when the universe was still emerging from dark ages. This tiny patch represents just 1/13 millionth of the entire sky. If every similar patch contains 10,000 galaxies, then the total number in the observable universe reaches into the trillions. Webb has now surpassed even these achievements, detecting galaxies completely invisible to Hubble and pushing the cosmic frontier back to just 280 million years after the Big Bang. There is an absolute wall in space beyond which we can never see. This cosmic horizon isn't created by a physical barrier. It exists because light has limits, and the universe hasn't existed long enough for photons from the most distant regions to reach us. At the edge of our observable universe lies the cosmic microwave background, the afterglow of the Big Bang itself, representing the last moment when the universe became transparent to light. It formed roughly 380,000 years after the Big Bang, when the universe cooled enough for electrons and protons to combine into neutral hydrogen. We can't see anything before this moment, because no light from earlier times can reach us. The observable universe extends roughly 46.5 billion light-years in all directions, giving it a diameter of about 93 billion light-years. This distance is larger than expected for a universe only 13.8 billion years old because space itself has been expanding while light traveled toward us. The cosmic microwave background provides a baby picture of the universe, showing tiny temperature fluctuations representing seeds of all future structure. Modern satellites have mapped these fluctuations with extraordinary precision, revealing the universe's composition, age, and fate. Outside the boundaries of everything we can ever observe lies infinite mystery. The universe doesn't end at the cosmic microwave background. That's just the limit of what we can see. Beyond our observable horizon, space continues indefinitely, potentially forever, containing galaxies, stars, and structures identical to what we see around us. Current measurements suggest the universe is geometrically flat, which in cosmological terms means it's very likely infinite in extent. If true, then our observable universe represents a tiny bubble within an infinite ocean, containing infinite galaxies, infinite stars, and infinite copies of every possible configuration of matter. In an infinite universe, every possible arrangement of atoms must occur somewhere, including exact copies of Earth and even you. The mathematics are staggering. In a volume roughly 10 to the power of 10 to the power of 118 meters across, every possible quantum state would be exhausted, forcing exact repetition. Somewhere beyond our cosmic horizon, perhaps unimaginably far away, there's another planet identical to Earth where another version of you is having exactly the same thoughts. But infinity contains more than just identical copies. It also contains every possible variation, versions of Earth where dinosaurs never went extinct, where you made different life choices, where entire histories unfolded along completely different timelines. Every possibility that doesn't violate physics exists somewhere in infinite space. After flying through 2 trillion galaxies across 13.8 billion years of cosmic history, we return to the most profound question: what does this mean for us? Every galaxy we've explored formed through the same fundamental processes that created our Milky Way. The carbon in your body was forged in stellar nuclear furnaces that exploded billions of years ago. The oxygen you breathe came from stellar death throes. You are literally made of star stuff, recycling through the cosmic web for eons. In a universe containing 2 trillion galaxies, each harboring hundreds of billions of stars and potentially trillions of planets, the mathematical certainty is that we are not alone. Yet despite this statistical certainty, we remain practically alone in our observable universe. The distances are so vast that meaningful contact with other civilizations may be forever impossible. We've discovered our true place in a universe far grander than our ancestors imagined. Earth orbits an ordinary star in the outer reaches of a typical galaxy, just one member of a modest galaxy group in an unremarkable region of a vast supercluster that itself is merely one node in an infinite cosmic web. From this perspective, every human conflict, every political boundary, every economic system seems absurdly small. Yet the cosmic perspective also reveals the extraordinary preciousness of what we have. In a universe dominated by radiation, plasma, and dark matter, planets capable of supporting complex chemistry and life are rare cosmic treasures. Earth represents billions of years of cosmic evolution concentrated into a single world where the universe became conscious of itself. We are the universe's way of knowing itself. Through human consciousness, the cosmos has developed the ability to contemplate its own existence and predict its future across unimaginable spans of time. We live in an age of unprecedented discovery. Never before have we been able to see so far into space and time, to understand so much about our cosmic origins, or to appreciate the true scale of the universe we inhabit. Webb and future observatories will continue pushing back the frontiers, revealing new types of galaxies and deeper insights into the fundamental nature of reality. Perhaps the most important lesson from our journey through 2 trillion galaxies is that the universe is far stranger, more beautiful, and more awe-inspiring than we ever imagined. From dark matter scaffolding to galactic cannibalism, from impossible early galaxies to cosmic web filaments spanning billions of light years, reality consistently exceeds the limits of human imagination. We end where we began, as temporary arrangements of atoms in an infinite cosmos, but now with the knowledge that we are participants in the most extraordinary story ever told, the evolution of the universe itself from simplicity to complexity, from darkness to light, from unconscious matter to conscious beings capable of contemplating their own cosmic significance. Flying through every galaxy in our observable universe brings us home to Earth with deeper appreciation for both our cosmic insignificance and our cosmic importance. We are small, temporary, and isolated in space and time, but we are also the universe's greatest achievement, matter organized in such a way that it can understand its own existence and contemplate the infinite mystery that surrounds us on all sides.